This is potassium chloride. KCl, right?
Yeah.
Grab some. Put it right in here. Okay. This is.
Assistants.
You're famous. You're on TV.
This is
You're not in the picture right now.
calcium carbonate. CaCO3.
That's chunky.
Alright. Take this, stir it up. Take this, stir it up.
Didn't you just
There we
cross-contaminate that?
What's that?
Didn't
Yes,
you
I
just-
did. That's the whole chapter right there. Okay? Two test tubes. Clearly, KCl is more soluble than calcium carbonate, which is very insoluble. Does that make sense?
Yeah.
That's the chapter. Okay? So, KCl, when I put solid KCl in water, okay, it dissolves into K positive and Cl negative. Alright. When I put calcium carbonate in water, it breaks down into calcium plus 2 and carbonate negative 2. Alright. So what would the K value be for this? Very, very large or very, very small?
Large.
Why large?
It favors the products.
Does everybody understand that? He says it's large because when I put the KCl in water, what did it do?
It's more soluble, so it breaks down.
Yeah, where's soluble? Over there. It dissolves in water into this and this. When I put the calcium carbonate in water, it did this thing, but where is the majority of it? Right there. You see the cloudy, chunky butt stuff? You see how we can't even see through it? That's because the majority of this system is over here. Does that make sense?
Mm-hmm.
That guy, soluble. This guy, insoluble. This guy, what kind of K value?
Large.
Large. This guy, K value?
Small.
Small.
Did you just make up those numbers?
Those are the real numbers. Okay? And we call this KSP. Okay?
What does that
So,
stand for?
here's the list again. We've got KC, KP, KW, KA, KB, and KSP. And this is the last one. Okay?
What does it stand for?
This stands for solubility product constant. We'll
Okay.
get to that in a second. Okay? Alright. So, if I was going to write the K expression for this, KSP expression, what would it be?
K positive.
K positive
Cl negative.
times Cl negative all over nothing.
Nothing.
Because that's a solid. Right?
We need
What would the KSP expression be for this down here? Calcium ion times
CO3.
CO3 negative 2. Does that make sense?
Yeah.
Alright.
Alright.
This list right here. Isn't that the solubility list? Okay, those are the rules that you memorize. Okay. These things are all soluble up here, which means they have what kind of K value? Large. These are all insoluble here, which means they have what kind of K
Small.
value?
Small.
Small. Does that make sense? Once again, soluble, so their K value is large. How are we doing with this?
Phenomenal.
Okay. Alright, doing great. So KSP, you asked, stands for what? The solubility product constant. Okay, vocabulary, there's going to be only two major vocabulary words. Of course, those aren't words. That you need to memorize for this. KSP is the solubility product constant. So if I have some sort of salt, AB, and it dissolves into A positive plus B negative, then its KSP is just going to be the concentration of this times the concentration of that. Okay? If I have AB 2. It gives off A plus 2 and 2B negatives. Then Ksp is going to be what? A plus 2, the concentration of A plus 2 times the concentration of B negative squared. We cool with that?
Yeah.
Okay. This little thing over here says the magnitude of the solubility product constant is related to the solubility of the salt. Meaning, the larger the K value, the
More soluble.
more soluble. The smaller the K value, the
Less.
less soluble. Okay? Alright. So here's silver chromate. Silver chromate has a Ksp value of 2.6 times 10 to the negative 12, which is freakishly what?
Small.
Small, which means it's very
So
insoluble. Stays over here. Not a lot of it dissolves. Okay. So wouldn't its Ksp expression be Ag positive squared times chromate? Yeah? Okay. So before I add the water to the solid, kind of like I did right here in that demo, okay? Then this is 0 and this is 0, right?
Yes.
Alright. So this is going to gain x, gain 2x. Okay, so that's going to be x, and that's going to be 2x. So if I take this and plug it in here, take this, plug it in here, I get Ksp equals 2x squared times x. Right? What is 2x squared times x?
2x to the first.
4x squared times x. 4x to the third.
4x cubed. That's right.
Yay!
Okay? 2 squared is 4. X squared times x is x to the third. Okay? So I'm going to have to take this, divide it by 4, and then do the cubed root on your calculator. I think if you press math, function 4 maybe, and then you can choose what you want to do there. When you solve for x, you get 8.7 times 10 to the negative 5th. This is the last important part here. Ready? That is called your molar solubility. That's the second vocabulary word that you need.
Which is the molar solubility?
X. When you solve for x, it's the molar solubility. That's the minimum molarity that you need to be saturated. Anything more than that, it's a saturated solution. Anything less than that, it's not saturated. Let me say that again. Anything more than this value, you have precipitate. Anything less than this value, no precipitate. Okay? So this test tube right here is more than its X, more than its molar solubility. That's why it's chunky butt. You can't see anything.
Is there anything with a Ksp of 0?
No, not 0. It's got to be a value, actually. Okay. This thing right here is less than its K value. It's pretty clear. Okay? Those are the two definitions that you have to know for this unit. Molar solubility is X, and this guy right here is called what? Solubility product constant.
Wait,
Okay.
so if you have more than X, it's insoluble, and you have less than X, it's soluble?
Yes. Alright, so here we go. Magnesium hydroxide. From what you know about your solubility rules, what would you say its K value is?
Small.
Why?
Because it's
Because it's not.
What rule? What do you
OH negative.
Hydroxides tend to be
Insoluble.
insoluble. If it's insoluble, its K value is going to be
Small.
small. Okay? Matter of fact, it's 1.8 times 10 to the negative 11.
It's
Okay.
quite small.
What would this look like? MgOH2, which is a solid, would dissolve into Mg plus 2 plus 2 hydroxides. They will ask you to write this equation out.
Even if it's...
That's called gimme points when they do that. Then they're going to ask, what is the solubility product expression? The K expression. What would it be?
Mg.
Concentration of magnesium times the concentration of hydroxide squared. Okay? Alright. Well, if you're doing an ice chart, I'm not going to use this guy because he's a solid, right? This will be 0, this will be 0. This is going to gain x, this is going to gain 2x. X, 2x. So if I plug it in here, Ksp, which is 1.8 times 10 to the negative 11, equals x times 2x squared. That's going to be the same thing as 4x cubed. Will you guys please solve for x?
How we doing?
Good.
Which means divide that by 4 and then take the cube root of it. Does anybody have an answer?
1.7.
1.7
times
negative 4.
Yes.
Okay? And once again, that is called your what?
Minimum molar.
Molar solubility. That is called what? Solubility product constant.